Okay, 7.4 trigonometric equations. We're going to start talking about how to solve trigonometric equations both in general and also over one period. So right here I just have solve. Cosine of theta equals negative root 2 over 2. Let's go ahead and start that one. So if I want to solve something like this, guys, what I'm looking for is all values of theta such that cosine of theta equals negative root 2 over 2. So we know that cosine of theta equals negative root 2 over 2. That is, when is the x-coordinate on the unit circle equal to negative root 2 over 2? Well, we know that happens when we have this angle right here, right? Cosine of this angle, theta. So this is a distance of negative root 2 over 2, which is 3 pi over 4. But it's also actually equal to pi over 4, or excuse me, 5 pi over 4 here. So I've got two values such that cosine of theta equals negative root 2 over 2 in 0 to 2 pi. So the way I write this is the following. I write theta could equal 3 pi over 4. Theta could also equal 5 pi over 4. That gives me this guy and that guy as terminal points. But also notice that if I did 3 pi over 4 plus another full circle, which is 2 pi, I'd also have another solution. And this just says solve, which means I want all the possible solutions. Or if I went 3 pi over 4 plus 4 pi, I'd also have a solution. Or 3 pi over 4 plus 6 pi, I'd also have another solution. So for what I'm having is I'm having any integer multiple of 2 pi added to this gives me another one of these values that give me a terminal point here. So the way I write that is I say, you know what, it's going to be 2 pi times any integer k, where k is an integer, okay? So 3 pi over 4 plus any multiple of 2 pi, that's what this is, any multiple of 2 pi. Now it could be a negative integer, it could be a positive integer. Right, if I went 3 pi over 4 and then negative 2 pi, I'd also get the same spot. Same thing with 5 pi over 4, so I'd have 5 pi over 4 plus 2k pi, where k is an integer. So these are my general solutions for this equation, okay? This has an infinite number of values, this has an infinite number of values. Okay, but they give us, both together they comprise all the solutions to cosine theta equals negative root 2 over 2. Okay, similarly, we can do the same thing for sine of theta equals negative root 3 over 2. Okay, we've got a unit circle. At what value theta does sine of theta equal negative root 3 over 2? So I want, if I go 1/2 comma root 3 over 2, I have negative 1/2 comma root 3 over 2, 1/2 comma root 3 over 2. Down here is where I get a height of negative root 3 over 2. This is the point 1/2 comma negative root 3 over 2, negative 1/2, and this is 1/2 comma negative root 3 over 2. So the question is, for what values of theta does this happen? Okay, so my x-coordinate is negative 1/2. My y-coordinate is negative 3/2. We know that happens at pi plus pi over 3. Okay, so it's 4 pi over 3. So one of my solutions will be theta equals 4 pi over 3, but also theta equals, right, 4 pi over 3, 5 pi over 3, 5 pi over 3, plus any integer multiple of 2 pi. So I say plus 2k pi plus 2k pi. And what that does, that gives me all possible values of theta for any integer k, such that sine of theta equals negative root 3 over 2. Alright, now what we're going to do is we're going to talk about finding cosine of theta equals 0.65. 0.65 is not one of those special values that's on our unit circle, but we still have techniques to be able to solve it. You know, one of the things we can do is we can look at, if we have cosine of theta equals 0.65, we can think of taking like cosine inverse of both sides. So we know that cosine inverse of 0.65 equals theta. So we're just using our calculator at this point. Okay, and if you plug that into your calculator in radio mode, I think you get theta equals approximately, I think, 0.86. Okay, so approximately 0.86. Now, because cosine is a period of 2 pi, we can find the solutions of that in any interval length of 2 pi. So what we do is we note that if we've got this one, theta equals 0.86, right? Well, we also have 2 pi minus 0.86 to be the other value. Okay, so we know that if theta equals 0.86, then 2 pi minus 0.86 is also another value of theta. Okay, so if I go 2 pi minus 0.86, I think you get roughly 5.42. So I'll have theta equals 5.42 approximately. Right? So we've got theta equals 0.86, theta equals 5.42. Make sure that, when if we say solve, we want all possible solutions. So I'll put 0.86 plus 2k pi, and over here, theta equals, and over here, theta equals 5.42 plus 2k pi. Okay. Good. So if I have a non-special value for when I have a trigonometric function equals a non-special value, just use your calculator. Now on number 4, what I did is I put some, I dressed it up a little bit, made it look tougher than it actually is. The way you do that is you simply solve for sine theta first. If I solve for sine theta, subtract 1, I get 2. Sine theta equals -1. Therefore, sine theta equals -1/2. That is one of our special values. We go back to our triangle, or back to our unit circle. Okay, when is sine of theta equal to? This pen just died on me. When is sine of theta equal to -1/2? Well, that's right here and right here. Okay, so this is √3/2 comma -1/2. This is -√3/2 comma -1/2. Okay, and that happens at where? At pi plus pi over 6, which is 5 pi over 6. So I have theta equals 5 pi over 6, and also 2 pi minus pi over 6, which is 11 pi over 6. And of course we want all possible values, so I put plus 2k pi, plus 2k pi. Now, suppose I had said, I just want solutions, say, in the interval 0 to 2 pi. Maybe I said, solve this in this interval. If I wanted to solve this guy in this interval, well then I'd have 5 pi over 6, and I'd have 11 pi over 6, but I wouldn't need to put plus 2k pi also. So my answers would just be 5 pi over 6 and 11 pi over 6. I'd eliminate the plus 2k pi. This is for when we want to solve it for any value of theta. If I just want to solve it in this interval, I just want to find those guys. Okay, 2 more for us. Suppose I have 4 cosine squared theta minus 4 cosine theta plus 1 equals 0. How do I solve something like this? Well, if you think of, instead of seeing it as cosine theta, you see it as like an x. Like, how would you solve 4x squared minus 4x plus 1? Well, you'd factor it. Well, we're going to do the same thing here. And if you factor this, and it does factor here, I think you get 2 cosine theta minus 1 and 2 cosine theta minus 1. So then, using the zero product property, I have 2 cosine theta minus 1 equals 0, or 2 cosine theta minus 1 equals 0. This happens, if you solve one, you solve the other. So I have here cosine of theta equals 1/2. So when does that happen? Well, cosine of theta equals 1, if we draw our little unit circle, we want cosine, the x value, to be 1/2. That puts us the y value at √3/2. So I have 1/2 comma √3/2. Okay, that also gives me over here this guy. That's also when I have a positive value of 1/2 for my x-coordinate, so that's pi over 3, so I have theta equals pi over 3 plus, also in addition we have theta equals 2 pi minus pi over 3, okay, so that's 5 pi over 3 plus any interval, any multiple of 2k pi, because I didn't put in a specific interval, so plus 2k pi and plus 2k pi. Okay. So I just solved this for all possible values of theta just to solve this equation. Okay. Factor zero product property, solve each one of the trigonometric equations. Okay, next one. Suppose in this one we have something like this. Well, this is not one of those ones that you'll go through the kind of the factoring process that we did here. Here we'd factor out a greatest common factor, which is tangent theta. And what we're left with is 3 sine of theta minus 2. And that equals 0. So then we have tangent theta equals 0, or 3 sine of theta minus 2 equals 0. Well, this happens when sine of theta equals 2/3. Over here, this is when does this happen? This happens when theta equals 0. Okay, plus 2k pi. Over here, we do sine inverse of 2/3. And that is my angle theta. We find out the value of this. We go 2 pi minus it. So we'll have 2 pi minus that sine inverse of 2/3 is also a value. So we'll get this guy, whatever that turns out to be, plus 2k pi. This guy plus 2k pi, and that guy right there. And that gives us our 3 solutions for this trigonometric equation.